Okay, so in this lesson, we're going to look at right triangle similarity, and this is also going to include the geometric mean as well as the geometric mean altitude theorem. So let's take a look at the right triangle similarity theorem. That basically states that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and they are similar to each other as well. So if we look at this large triangle here, triangle ABC, the altitude would be drawn from B to side AC, which is the hypotenuse. And we know that AC is the hypotenuse because in this large triangle, angle B is the right angle, right? And we know the hypotenuse is always opposite the right angle. So this would be our altitude here, and it would be perpendicular to side AC, meaning it makes that 90-degree angle. And we can separate the three triangles here, those two smaller triangles, ADB, CDB, and ABC, paying close attention to the angle arc marks. And when we do that, we can write a similarity statement. So triangle ADB is similar to triangle BDC, which is also similar to triangle ABC. So just taking a look at the first letter in each triangle here, and we're referring to the angles. So angle A, B, and angle A. So let's take a look at angle A in the first one. It has that one congruence mark. Angle B in the second one, that one congruence mark. And then angle A, third one, the largest one, has that one congruence mark. So the angles should line up or be in the same position in your similarity statement. And using that similarity statement, we can write proportions. So these are the three proportions we could write. AD over AB, BD over BC, AB over AC. If you notice with AD it is the first two letters in that first triangle. BD, first two letters in that second triangle, and AB, first two letters. All right, if we look at the bottom, AB, or in the denominator, it's the first and third letter in that first triangle. BC, first and third letter. AC, first and third letter. So those angles are in the same position, so we can write a similarity statement as well as write proportions for all three of these triangles. So let's take a look at these two examples here. We want to find the value of x, and we could set up proportions to find the value of x. So for the first one here, my first proportion would be x over 12 because I'm using the altitude and the hypotenuse of that smaller triangle. And I could set it equal to the altitude, which is 9, in that larger triangle, to the hypotenuse of my larger triangle right here, which is 15. And then I would just solve that proportion. Cross multiply, and we get 108. 9 times 12 is 108. Solving for x, and x is equal to 7.2. All right, so let's try the second one here. All right, so my smaller triangle, or the triangle on the inside here, my altitude is x, hypotenuse is 21, larger triangle, altitude is 11.2. Remember, it is not the hypotenuse, it is just that perpendicular line that is drawn from a vertex to the hypotenuse. And the hypotenuse of this larger triangle is 23.8. And again, we know that because it is opposite that right angle here. Okay? Solving that proportion, we just cross multiply. So that would be 23.8. X is equal to 235.2. Let's cross multiply. Left with that one-step equation. 235.2 divided by 23.8 will give me 9.9. So x in this case is 9.9. All right, so why don't you pause the video and try this problem on your own, finding the value of x. All right, so you should have gotten x is equal to 6.72. Hopefully you got the answer correct, setting up those proportions. All right, so what is the geometric mean? The geometric mean of two positive numbers, a and b, is the positive number of x such that a over x is equal to x over b. Therefore, if we cross multiply, we can conclude that x squared is equal to a times b, and x is equal to the square root of a times b, because remember the inverse of something squared is to take the square root of it. So if we were to take the square root of x squared, we would be left with x is equal to the square root of a times b. So let's take a look at some problems involving finding the geometric mean. All right, so let's look at these two examples. We want to find the geometric mean between 6 and 30 and 16 and 28. So we can label 6 and 30 as A and B, or vice versa, it does not matter. So I can set up my proportion as 6 over x is equal to x over 30, as long as your x's are opposite each other. So when you cross multiply, you get x squared. All right. So simplifying this, or cross multiplying, x times x is of course x squared. 6 times 30 is 180. Taking the square root of both sides to get rid of this x squared here. We want to write it in simplest radical form, so finding two factors of 180, where one of them is a perfect square. Our largest factor that's a perfect square would be 36. And 36 times 5 would give me 180. And my last step is to simply take the square root of the perfect square. So the square root of 36 is 6, leaving the imperfect square under the radical. So we're left with 6 times the square root of 5. That is the geometric mean of 6 and 30. Let's take a look at this one here. We can set it up as 16 over x is equal to x over 28. Cross multiply, x squared, 16 times 28 is 448. Finding those factors, we could use 64 and 7. The square root of 64, which is the perfect square, is 8. And the imperfect square is 7. Leave that under the radical. So we found the geometric mean of these two numbers as well. Let's take a look at the geometric mean altitude theorem. That is, the length of the altitude is the geometric mean of the lengths of the two segments. So my altitude here for this large triangle is BD. So that's basically stating that the altitude BD squared is equal to AD, which is here, side AD, times DC. All right, so let's look at some problems involving the geometric mean altitude theorem. All right, so using the geometric mean altitude theorem, we want to find the value of x. Now what I can do first for this first problem, I could set up a proportion. X is my altitude right here. I could write this as x over 8 is equal to 12 over x, or using the geometric mean altitude theorem, I could say that BD, which is my altitude, so basically your altitude is equal to, or altitude squared, so x squared is equal to AD, but in this case we have 12 and 8, so that would be 12 times 8. And we could see that if we cross multiply using this proportion, we will get the same results, right? And so simplifying, x squared is equal to 96 square root. Two factors are 16 times 6 And the square root of 16 is 4, leaving an imperfect square under the radical. Let's try this one here. So we have this whole side length of 37. So if this piece is 5, right, then this piece would have to be 32. We simply subtract it, 37 minus 5. So now setting up our equation here, we could say that x squared is equal to 5 times 32. All right, and we get 160. Taking the square root. My perfect squares, or a perfect square that is a factor, would be 16 times 10. And so my final answer would be 4 square root of 10. Alright, so we've used the geometric mean altitude theorem to find the value of x for these two problems. Let's take a look at these two examples here. So if we notice, our altitudes are given. We have 18 here for our altitude and 21 here. Alright, but we could still use the geometric mean altitude theorem. So in this case, BD, our altitude, right here would be 18. So 18 squared is equal to 15 times x. 18 squared, 324, is equal to 15x. And we just lift up that one-step equation. 324 divided by 15 is 21.6. So in this case, we've used the geometric mean altitude theorem to find one of our missing segments. So let's try this second one here. All right, so altitude is 21. So that would be 21 squared. It's equal to, so this length is 30. And we don't know this length here. We know that we want to find x, right? So we don't know this length right here. So I'm just going to label it y because we have to find that first. So I'm going to do 30 times y because we don't know what this length is. So 21 squared is 441 is equal to 30 times y. Solving for y. 441 divided by 30 is 14.7. Alright, so we've gotten 14.7 for this length right here. So x is basically, we want to add 30 plus that 14.7. It's a little different there, but we still use the same theorem. And that is equal to 44.7. Alright, so let's try some problems on your own. I would like for you to go ahead and pause the video and try these 4 problems on your own. So go ahead and pause and try these problems using the geometric mean altitude theorem. Alright, so hopefully you got the answers correct. Go ahead and just pause this video at this point to go over your answers and check them and to see if you got them all correct. Alright, we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are the Pythagorean theorem and the converse, as well as special right triangles. If you haven't done so already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.